So I'm going to jump into a different VPN managed service, AWS Client VPN, that allows you to connect your remote users, maybe working at home or sitting in an internet cafe, connect them over to your AWS resources and beyond. So the managed client VPN allows you to automatically scale capacity based on the number of your users. It also gives you the ability to provide granular access controls on what your remote users actually will be able to connect to. And finally, it integrates with the familiar components that you already know, like the VPC or Active Directory. So let's start off with going over how you would deploy the client VPN, and then we'll look at how the actual connection establishment is happening. So on the left-hand side, we have a VPC that we want our remote users to connect to. On the right-hand side, we have an example remote user with their device, maybe sitting at home, waiting to connect. So that VPC on the left, we'll refer to this as a target VPC. This is the VPC that all of your users connecting to the VPN will be emerging in. So this is where they appear on the AWS environment for the first time, and then you can decide when they can go next. All right, so the first step is for you to create the client VPN endpoint. This is what your remote users are going to be establishing their connections to. So when you create the endpoint, there's a number of options that you will have available. Initially, you'll be able to name the endpoint, give it a description, but also decide on the IP address range that will be assigned to any remote users connecting to the service. The second part is when you decide on what type of authentication you want to use for your remote users. Firstly, you will specify the server certificate to validate the client endpoint to the users. And the next step is to decide how do you want your users to authenticate. And we have two options. You can use Active Directory authentication, or you can use mutual authentication, so certificate-based authentication. So how these two compare? So with certificate-based authentication, you have to use AWS Certificate Manager to either import your own private certificate or use the private certificate authority feature to create your own certificate, just like Nikhil explained earlier for site-to-site VPN. If you decide to use Active Directory for authentication, you have to use the AWS Directory Service. It allows you to either create your own managed Microsoft Active Directory or use a AD connector, which allows you to effectively proxy AD connectivity to your Active Directory on-premise or deployed somewhere else in your environment. We also, with Active Directory, support multi-factor authentication. And this is done through integrating your AD with Radius MFA. Once your authentication is configured, you will then be able to set up the logging. So if you want to start logging your users connecting to your service, we can start sending the logs to CloudWatch, and you will need to specify the log group name under which you want all your logs to appear in the service. And if we take a sample log, this is how it might look like. This is an example of an initial connection log. So it shows you that the user has successfully connected to the service. You will see details like the timestamp, so when has the connection occurred. At the bottom of the page, you also see where the connection has ended. However, in this case, this is just the initial connection, so it hasn't ended yet. You'll also be able to see the name you allocated from the certificate that the user has received. You will see what device the user is coming from, what public IP address they're on, and also what is the private IP address that got allocated to your remote users from the pool you defined earlier. Okay, so final options on the client VPN endpoint configuration is to define the DNS servers you want to push to your remote user and what type of protocol you want to use for transport, whether it's going to be TCP or UDP. Typically, the faster option is to use UDP, but you may have firewalls out there that would not allow port 443, which is what the service is using, over UDP, so you might have to switch it to TCP if necessary. We also give you the option to enable split tunneling. So split tunneling allows you to decide exactly which traffic should be sent over the tunnel and which traffic you're allowing the users to send directly to the internet, effectively bypassing sending it through your VPN connection. So we've configured our endpoint. We've decided on what authentication options we want to use. So what's missing? The final step is to actually associate that endpoint with your VPC. And you do that by creating associations with different subnets inside your VPC. This is how it would look like in the console. The client is actually being provisioned. You will see it's in pending state. And the recommendation is to create multiple associations for high availability. So you want to associate your VPN endpoint with more than one subnet. And once at least one of those associations become active, the whole state of the VPN will go from pending to active, and then it's ready to kind of receive the connections. But there's 3 final steps that we need to complete to actually be able to decide what the users can connect to. These are security groups, setting up our authorization, and finally deciding on what do we want the users to be able to route to. So let's start off with security groups. So if we zoom a little bit closer into how those subnets associations appear inside the VPC, you'll see that there's an elastic network interface in the end of each one of those associations dedicated to your client VPN endpoint. And you set up a security group. That security group effectively is used to identify the traffic coming from users connecting to the client VPN endpoint. So in this scenario, it's not used as a kind of allow or deny function. It's more, think about it more as a tagging functionality. So you can use it as a reference in different security groups on maybe on your EC2 instances and say, I want to allow traffic from this security group belonging to the client VPN endpoint. And we'll dive into this a little bit more at the later stage as well. So once you're done with security groups, that's where we can move on to actually setting up authorization. So here is when we're deciding on which IP address ranges you want to allow your remote users to connect to. So with your authorization rule, you can specify exactly what IP address range, what network are you allowing your users to connect to. And you can either make it available to all users, or you can change permissions depending on which Active Directory group that user belongs to. So you may want to allow engineering to have access to one address space and then have marketing connecting to a different address range. And you can do that through using Active Directory groups. Once authorization is complete, the final step is to set up your route tables. And the route tables effectively go back to that split tunnel functionality I mentioned earlier, which allows you to decide which traffic should go over the VPN and which shouldn't. And by default, all the traffic to the target VPC will always go over the VPN, but we can add additional ranges if we want to allow our remote users to connect beyond just that VPC. Maybe we want them to connect to a peered VPC or somewhere else. So at that point, our client VPN is deployed. We've configured all the authorization and routing details. We can start connecting. So before we start connecting, we actually provide you the client configuration. So when your VPN endpoint is ready, you can download the client configuration and then use it on the remote user software, import it as a profile that the users will use to connect to the service. So when the users are connecting, they will need to use an OpenVPN-based software. So for Mac users, this might be TunnelBlick. For Windows users, this could be effectively OpenVPN. They have a client for Windows. And once you import the profile and initiate the connection will establish to the client VPN endpoint. That's where we'll apply the authentication and authorization to decide, okay, who are you? What are you allowed to get access to? And from there, if everything is successful, that user can get access to services deployed inside that VPC. But if you want, you can start allowing users to actually connect beyond that VPC. So you can get them to connect to your on-premise environment over Direct Connect or VPN. you can allow those users to connect to other VPCs through the transit gateway or through peering. And then finally, you can have the users connect directly out to the internet through that VPC or to other AWS managed services that live in that public address space outside of your VPC. So to get a little bit of a better picture of how it looks like, we can do a packet flow or packet walkthrough for some of those use cases. So let's start with a scenario where we have a VPC. We have our subnet associations. And as you see here, we actually gave those Elastic Network Interfaces IP addresses. So these will be auto-assigned where the associations are created. We're assuming the user can connect to the service. And there's a security group wrapping around those Elastic Network Interfaces as part of the configuration of the client endpoint. And we want to allow our remote users to connect to a peered VPC. So that VPC is now 10.1. Inside, we have an instance, 10.1.0.10. There's another security group protecting that instance, and we have a peering relationship. So we've configured the peering, we've configured the routing. So VPC 10.0 can communicate with VPC 10.1, that's great. So if we want to allow remote users to connect to that instance, we can now leverage the security group capability. So we can say in our security group B, the one that protects the instance, that we want to allow maybe SSH traffic, if these are your kind of remote administrators or any other traffic you want. We want to allow that traffic from security group A. So any traffic coming through those ENIs, they will be tagged with security group A and then will be allowed to connect to the instance. We also need to make sure that in our client VPN configuration, when we look at the routing and the authorization, we need to add that additional range of the other VPC we want to allow access to. So at that point, the user should be able to connect to the other VPC. And the way this would look like, initially, the user sends a connection from its own IP address. That's the IP address range assigned by the client VPN service. In this case, 10.100.0.10. And the target of this traffic is the instance on the left. Once the traffic, though, passes the association ENI, we actually do nothing there. So we will translate from the actual user IP address from 10.100 to the IP address that belongs to the ENI that's used for the association. And then we will forward that traffic to the instance on the left, effectively allowing for connectivity to work end-to-end. Another example I want to dive into is when our remote users want to connect out to the public internet, or maybe to other AWS services. In this case, it's actually quite simple. As long as the ENIs for the subnet association, so as long as the subnets we used are public subnets, those ENIs will also have a matching public IP address. So as long as we also update the client VPN configuration to authorize access to any ranges, so this means that traffic to any destination will always go over the tunnel, and we are also allowing that traffic to be passed through the VPC out to the internet. Once that's configured, the client will send the traffic to an internet destination from its own IP address. The ENI will be used to translate that user IP address to its own IP address, and it can be forwarded out through the internet gateway to the internet with a public IP address in the end. So if you notice here, we don't actually need to use the NAT gateway. So there's no requirement here to use the NAT gateway, and we can still allow the traffic from that remote user to connect to the internet. So finally, just to give you a recap of some of the new features that were launched throughout 2019. One of the features was split tunneling, and we covered that in more detail. We also launched the multi-factor authentication support for Active Directory. That's the Radius MFA service. And then finally, we've added support for CloudFormation, so you can automate the provisioning and creation of your client VPN service.